Dear colleagues and participants of the conference, my name is Viktor Zhukovskyy and I would like to present our analysis and prediction of humus balance in soils of Ukraine using the information tools. Well, we know that today's world agriculture production is focused on making a quick profit despite the effects of anthropogenic impact on the state of the land. First of all, it is manifest in the intensification of the crop sector, which is focused on increasing the sown area for energy crops. This situation is typical for Ukraine also. At the same time, the scientific community pays insufficient attention to a comprehensive study of the crop production intensification impact, including increasing production of soil depleting crops such as sunflower, soybeans, rapeseed, etc., and the level of land fertilization with organic fertilizers. We hypothesize that there is a close relationship between those parameters to use the identified interdependencies to harmonize environmental and economic interests in the field of agricultural land use at different levels of government. Also, we are developing the mathematical model to predict the change in humus concentration in some soil over the time. To identify the eco-destructive factors in the system of agricultural land use, we propose to investigate the impact on soil quality of land use, intensification in agriculture, as well as to assess volumes of production of organic fertilizers in the process of growing farm animals. The results you can use to determine the possibility of restoring the humus content in soils. According to the analysis of soil quality indicators by organic component, revealed a gradual decrease in the level of humus for the period 1990-2019. The dynamics of reducing the humus content in agricultural lands is noted in the some administrative regions of Ukraine. And over the past 25 years, the average humus content in Ukraine has decreased. There is on table 1, we can see the data for analysis which present volumes of technically achievable energy potential per 100 hectares of arable lands. On table 2, we see volumes of organic fertilizers per 1 hectare of arable land. Also, after that data collections, we made the cluster analysis of the Ukraine regions in the program Statistical version 10. The next properties were taken into account: the volume of technically achievable energy potential of cultivated crops, the volume of production of organic fertilizers, and the content of humus in the soils. The results of the cluster analysis in the Ukraine regions for 1990, 2000, 2010 and 2019 are based on the grouping of the studied indicators and are presented on table number 3. Also, we see on the table 4 the average values of quantitative indicators of the volume of the technically achievable energy potential of crops, organic fertilizers and humus content, according to our clusters. On the next slide we may see charts for car-beans clustering analysis for various years as the split of regions into 4 clusters, using our before mentioned 3 components. After that, we build the mathematical model which predict the change in humus content over the time. After some mathematical transformations, we may see that final equation, and also there is a figure number 2 which demonstrates the dynamics of soil humus content. Also, we developed our own information analytical system for organic agriculture and ensuring environmental soil stability. This electronic calculator consists from 2 parts, the back-end and the front-end sections, which use the modern software technologies like ASP.NET, MVC, HTML, CSS, AngularJS. On the next figure, we see the dialog box for Humus change simulation and utilization as an individual plant scenario. So user may select the necessary crops and may select how much fertilizers he would like to use for the specific crop. After that, system will produce the Humus status change report for these specific circumstances using the server-side numerical computation in accordance to the aforementioned mathematical model. Also, there is another option like rationale for all scenarios. The user can set the amount of funds available for the cost of organic fertilizers and the number of years he would like to examine. Then, using the Calculate All Choices button, the e-calculator launches the proper algorithm for computer simulation and economic calculations. And the user will then be able to select the option which best suits him in the terms of cost and environmental impact. For example, he may choose to increase the soil quality, or probably he may choose the option to gain money, for example. So let us summarize our research. According to the results of the study, it is established that to ensure the balanced use of land resources of the agriculture sector, it is advisable to take into account the impact of the state of land features. The analysis revealed the relationship between the intensification of agriculture activities, the level of production of organic fertilizers, and the quality of land, humus content in soil. A significant level of interdependence and clustering of the Ukraine regions in the period 1990-2019 was revealed after statistical processing data in the program Statistica. Also, we developed the information analytical system of organic agriculture, and this system incorporates the proposed method of humus balance calculation as an electronic calculator module. This calculator allows user to independently set the order of crops to be grown in rotation and the amount of organic fertilizers. As a result, the user can receive potential variations of the total humus content in the soil for various volumes of organic fertilizer application. And this kind of research could possibly helps to develop effective ways to increase soil fertility and lessen the influence of harmful anthropogenic elements on the quality parameters of agricultural land. So thank you for your attention, and we will be happy to answer your questions. Thank you.